Hello Chem students, we're going to do another video here. This will be on naming complicated organic structures. I'll do two pretty complicated structures in this video. They're the same two that are in our chapter 4 PowerPoint slides. Okay, so let's go ahead and get started. Okay, so first off, I highly recommend you be familiar with the functional groups. Okay, you don't have to have them exactly memorized, but that would be a lot better. This will help you in your nomenclature problems and drawing 2D structures into taking condensed structures and drawing them into 2D structures. Okay, so what I did was I put these in order of priority from our perspective. There are groups higher than carboxylic acids, but for us in our course, carboxylic acid is the highest, so that's number one. In our course, we will only name carboxylic acids as suffixes at the end of the name. Number two will be anhydrides. We could conceivably name these as prefixes, but the prefix name is very complicated. So if you get an anhydride, it will be the highest priority group, but you'll notice there's 2 carbon chains to name, and they will only be suffixes for us. When we get to the ester, we'll have more than one way of naming it, because it could be a lower priority group, and so you could have a prefix or a suffix name. And that's going to be true for many of the ones that come up here. Number 4 would be acid chlorides, prefix or suffix. Remember, the suffix is when it is the highest priority group. The prefix is when it is a lower priority group. Then we have amides. I only show a primary amide here, but if we put an R group in the place of these hydrogens here, an additional R group would make this a secondary amide, and an additional R group would make this a tertiary amide. We can name these as prefixes or suffixes. Nitriles have the carbon-nitrogen triple bond, prefix or suffix. Aldehydes, prefix or suffix. Ketones, prefix or suffix. Alcohols, prefix or suffix. Thiols, sort of like a sulfur alcohol, prefix or suffix. Amines, prefix or suffix. And again, with the amines, they're like the amides. If I put an additional R group here, that would be a secondary amine. And if I put a third group, that would be a tertiary amine. Okay. Ethers, now we reach a point where we just sort of consider these all the same priority, and they are only named as prefixes. So even if all you had was an ether, you would still name the ether part as a prefix. The same is true for sulfides, which are also called thioethers. And for nitros, only a prefix. For nitroso, which looks very similar, except only one oxygen, also only a prefix. Azidos, sort of a funny looking group, and there's a resonance structure for this, as there is for the nitro over here, but always a prefix. Okay? And then the alkenes are named at the end as part of the parent name, okay, sort of a suffix part of the parent name. And alkynes are in a similar way named at the end as part of the parent name. Aromatics are all over the place, so we won't stress these very much. I'll only give you 2 prefixes, phenyl and benzyl, and they'll be prefix names. And alkanes are basically the backbone of everything, so we started off our strategy learning how to name the longest chain and the branches and branches off of branches and so forth. Okay, this is kind of a small slide, but has all the things that we're looking for here, all the groups, the same ones I was just talking about above. And here I give you the prefix names. So that's going to be required for most of these guys, okay? Because there's only one highest priority group, and that's the only one you'll use the suffix for. In our course, the highest priority group will probably be a carboxylic acid, or an anhydride, or an ester. So you'll probably want to know all of these suffix names here. And some of them have multiple parts. So if you look at an anhydride, there could be 2 different chains, and they would have to be named separately. Or in the case of an anhydride, if they're both identical, you just have to name it once, alkanoic anhydride. For esters, there's 2 different chains. Very important to keep them separate. The R group or chain on the oxygen is a substituent, but it's a very special substituent, and so whatever it is here will be named in front of the name as a separate word, so there's a little gap here. And then the part that has the C double bond O is the high priority part, and that's named as a suffix O8. Okay, acid chlorides, very likely you'll get this as a prefix name, chlorocarbonyl. Amides, very likely as a prefix name. And they have two possibilities. You could call them carbamoyl. You'll notice there's some number signs here. That's their position on the parent chain. Or it could be called amido. I think amido is probably easier because the name of the functional group is amide. But you can use whatever you want. Okay, and there is a suffix name. Nitriles are carbon-nitrogen triple bonds, and so they are called cyano with a number. Do not put cyanide because cyanide's an anion. Excuse me. Cyanide's an anion from freshman chemistry. And if they're named as a suffix, you keep the E because nitrile starts with a consonant, so we don't drop that E. If we have an aldehyde, aldehyde has two possible ways of being named. One, if it's part of the longest chain, so it would have to be at the end of the chain. We would use the oxo prefix. If it's a branch, it's just a one carbon branch off the side, and it has a number, formal number for the location, or a side branch. And if it's a high priority group, it's suffix names over here. Pretty easy. If we have a ketone, which looks a lot like an aldehyde, okay, the only difference is the aldehyde has an H and the ketone has two R groups. So the ketone will have some internal position, and you'll probably need a number for that. Okay, so that would be the prefix name. When I was a student, we called them keto groups, so we had number keto. But that's not really used anymore, so we won't use it in our course. And the suffix name is -one, like ketone. Alcohols, these will usually be prefixes for us, just a simple OH, and that'll be hydroxy as the prefix. Don't use hydroxide because, again, that's an anion from freshman chemistry. And then suffix would be -ol, alkanol. Thiols look like alcohols except it's a sulfur, and so there's two names here. You could call it mercapto, or you could call it sulfonyl. Okay, sulfonyl is a little more modern. Since I'm a little older, I like mercapto. I like the way that sounds. And if it's the high priority group, then you would call it a thiol, and you would keep the E because T is a consonant. Those are the only two. Okay, nitriles and thiols, we retain the E. If we had an amine, a lot of ways of naming amines. If it's just a simple amino substituent lower priority, we could say amino. So that's kind of like if you look up above, amido. Okay, except this time it's an amine. And at the end, if it was the high priority group, there's a lot of ways of naming this, so we won't worry too much about that. But basically, they end in amine. It's just, is it an alkyl or is it an alkane? Okay, and then if we had an R group on both sides, we've reached a stage where there is no suffix. Okay, this is just the ether group is a low priority group, and one of the R groups will be less important, and so you'll name that like alkyl, except you'll drop the YL and put in alkoxy. But you would name it pretty much the same as if it was just a simple alkyl branch with the ending of alkoxy here. Thioethers look like ethers, except there's a sulfur. And for these, we take the less important part, and we call it alkyl, say there was an ethyl group. So we would say ethyl thio. Okay, so that's a little bit of a funny one, but that's a possibility. In our course, you would only get a very simple name, methyl, ethyl, propyl, something like that. And then we have many halogens, fluorine, chlorine, bromine, iodine, and so those are all fluoro, chloro, bromo, iodo. And if you had more than one, you would say di for 2, tri for 3, etc. Azides are N3. I have that written up above with one of the resonance structures if you want to take a look at that. And that has a prefix of azido. Okay, azido. And then if we had the NO2, that's called a nitro group. And so that has a prefix of nitro. Sounds pretty easy. I have that written above with the one of the resonance forms with the formal charge too. And then if we have just a simple N double bond O, that's called a nitroso group. Okay, so these are all pretty common groups. There are many other groups that you might see in organic and also biochem that we aren't covering. Alkyl branches, I assume that we've already looked at those and studied those, and you know how to name alkanes, alkenes, and alkynes. Okay, so that's what I'm assuming. So you might want to refer back to this as we go through and look at all the possibilities. It's this first column right here with the prefixes that are going to be the most important. As far as the length of the chains, we could have 1 through 19, which sounds pretty hard. But methane, ethane, propane, butane or just memorization. And you'll see if it's a branch, it's very similar. We just drop the A and E and add YL. So methane becomes methyl, ethane becomes ethyl, propane becomes propyl, butane becomes butyl. Once we get to 5, it's sort of just like the geometric figures you learned in elementary school. So a 5-sided figure is a pentagon, a 6-sided figure is a hexagon, but in our chain lengths, we'll have a pentane, hexane, heptane, octane, nonane, decane, undecane, which is basically like 110, dodecane, which is like 210, tri for 3, tridecane, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9. We won't go to 20, which has its own different name, icosane, but for us we won't do that. These seem to be pretty straightforward to me. Okay, I put a list of possibilities of steps that you could follow to name an organic structure. You could come up with your own, I'm sure, but I suggest whatever strategy you use, you take that approach every single time you name it. And then you'll get into the habit of addressing all the points that you have to meet. So what I have here for me is I say identify the highest priority group, number 1, and then name the longest continuous chain of carbons that has the highest priority group. All right? And then you're going to use those numbers to assign positions of things below. Okay, so you want that highest priority group to have the lowest possible number. For many of our groups, and certainly for the high priority ones that we use, carboxylic acid, or anhydride, or ester, that C double bond O will be carbon number 1. Okay, and if that's the case, you don't have to write 1 in front of the suffix name. You can just write the suffix name. Now you're going to use these numbers to indicate positions of any kind of branches you have and any kind of substituents you have. Remember, these substituents are going to have a special prefix name, which you can get off the list above. Okay, so put those at the beginning of the name. We use the numbers to indicate their position. Now, official rules say alphabetical order, but not in our course. In our course, just name them as you go down the line. Okay, so the first one you come to, number, name. Second one, number, name. Third one, number, name. Okay, that'll make it easier for you to name it, and it'll make it easier for me to grade it. Okay, so carbon 1 on any branches. Okay, this sometimes gets mixed up. Carbon 1 on a branch is the point of attachment. And you can put your pencil there and say 1, and then start counting out for the longest chain that you can find, or if there's some high priority group in one of the sub-branches, you can use that to count to. Okay, if there's any double bonds or triple bonds, those will go as suffixes on the parent name. So instead of an alkane, you'll have an alkene. Instead of an alkane, you'll have an alkyne. Possibly you'll have them both, alkene, ine, always in that direction. Okay, and each double bond, each pi bond, will have its own number. And on double bonds, you'll have to indicate also stereochemistry as a possibility for E and Z. Okay, if you have more than one pi bond, then we have to use a little prefix. So if you had 2 of them, you would say di. If you had 3 of them, you would say tri. If you had 4 of them, you would say tetra, and so forth. Now, if we put in something in front of the diene, if we have a di, it starts with a D, we have to put in a vowel for pronunciation. So if I say I had a butene with 2 double bonds, butadiene, we wouldn't say that. We would say buta, number, diene. So just remember that little detail. If both double bonds and triple bonds are present, then it's always the order of alkene, ine. Okay? You could even have multiple pi bonds. You could have alka, number, diene. Notice I dropped the E here because the ine would be a vowel. And then I have number, triine, because I have 3 of them. And then I would drop the E because the alcohol suffix I have here starts with a vowel. And then I put a number for the alcohol. Okay, that would be the prefix. Up here, if we had carboxylic acid, we wouldn't put that. We would just put oic acid, triinoic acid. Or if an ester, triine-O8, because they have to be number 1. The stereochemistry features you have to be familiar with will be E and Z for alkenes, and R and S for chiral centers. Oops, I put that R in the wrong spot. That should be over here. Okay, so you could take all of these stereochemistry features and put them in parentheses in front of the name. I think that's the easiest way to do it, and less likely to slip up and make a mistake when you embed them in the name. Okay, so a name will typically have like some stereochemistry features here. All the prefixes and branches with their numbers here. The parent name based on the longest chain. Okay, you had a list of the required ones up above. And then any double bonds or triple bonds you have, however many there are. And then whatever the highest priority group is, the suffix name right here. Okay, if the suffix starts with a vowel, you drop the final E. And if the suffix does not start with a vowel, like nitrile and thiol, then you keep the E. All right. So you want to approach every problem kind of the same way. If this works for you, good. If you have your own way, that's good too. Okay, so what I'm going to do is I'm going to start with kind of a simple skeleton and develop the name for that. And then we'll add in some branches, and then we'll add in some functional groups. Okay, so the first compound example we have here is going to be pretty complicated. But this is kind of like your learning device for getting through this. Once you know all these prefixes, okay, the numbers will change, but the prefix will stay the same. So I like to compare it to a deck of cards. Okay, you don't have any problem knowing what the cards are when you flip them up. Okay, you know their names. And so the functional groups, you want it to be the same way. So if I had an alcohol, which has a hydroxy prefix, wherever the alcohol appeared, it's going to be hydroxy. I'll just put the number location in front of the hydroxy with a hyphen. Okay, so let's take a look. So first off, what's the high priority group? So I have a list here. You can think about it. What's it going to be? Acid, amide, aldehyde, ester, or no correct answer. So when I look up here, I don't see anything special except this part right here. The C double bond O and then an R group. This is called an ester group. So in an ester, we're going to have two parts. We're going to have to name this part over here. And this is the high priority part because it has the double bond O. And we're going to name this part over here, which is the lower priority group. In fact, it's going to be a branch. So we'll name it like a branch, YL, but it's on the oxygen. So since this branch is so important, we're going to put this in front of the entire name as a separate word. Now remember, you always number branches from the point of attachment. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our 11 carbon chain would be an undecane. But you'll notice there's two double bonds. So we're going to change that undecane to undeca, and then a number, diene. So the number would be 1, 2, 3, 4, 5, the lower number, 6, 7, 8, 9. So a 5, 9 diene. Okay, so it'd be very simple. And then on this side over here, we number from the first carbon of the functional group, which is the carbonyl group here. 1, 2, 3, 4, 5. I come to a double bond again. 6, 7, 8, 9, 10. We come to a triple bond. 11, 12. So this time we have 12 carbons. So the parent name will be dodecane, but we have a double and a triple bond. So it'll be a do-des 5-ene, because we always do the ene first, 10-ine. And then the ine's going to drop the E and add the suffix for an ester, which is O8. So let's take a look at what that's like. Okay, so name this part first, down here, undeca 5E 9Z diene ill because it's a substituent, do-des 5E ene 10-ine O8. And I forgot to mention the E and C. Remember, when you have a double bond, you can draw a line through the middle here. And if the high priority parts, based on atomic number, are on opposite sides, as is the case here, okay, then this will be an E. It comes from the German word Angegen. On this one here, at the 10 position, or 9 position, we have the higher priority groups on the same side. So we'll call this one Z. So remember, if Z same groups are on Z same side, it's Z. All right, on the other side, the large groups are on opposite sides, so we'll call this E. Okay, so again, 5E. There is no E or Z on triple bonds, so we don't have to worry about it. It's just a 10-ine. Okay, so this is kind of a straightforward name here. It's just got a lot of carbons, so it looks a little bigger, but there's only one functional group. So our next example, we're going to take this same skeleton and add a few branches to it. Okay, so now we want to provide a name for this. So I kind of highlighted everything the same, except I did add an extra methyl down here. Now when I added that extra methyl, it made these two groups the same, so no longer is there an E and a Z. There is just no stereochemistry here. So let's come over again. We again have the ester. So our branch point starts right here in the oxygen. 1, 2, 3. Now we got a branch at 3. 4, 5. We got the double bond. 6. We have this aromatic ring. 7, 8, 9. We have another complicated looking branch. 10, 11. Okay, you can pick either carbon here. And on this side we have 1, 2. Now we got this aromatic portion we have to name. 3, 4, 5. Still our double bond here. 6. Now we have a complicated branch here to name. 7, 8, 9. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's the same. So let's see how we'll do this now. All right. So I come down here 1, 2, 3. So I'm going to have a 3 in front of parentheses because this is a complicated branch. I number from the point of attachment. So 1, 2, 3, 4, 5, 6, 4, 5, 6, 7. So we go the longer pathway, and then this becomes a sub-branch. Okay. So at the 3 position, we will have a 4-ethyl and 7 carbons as heptyl. Remember, YL is the ending for a substituent. This has a special name, you just got to know it. Just a benzene ring all by itself as a branch is called a phenyl. And then down here we have a ring, so that's going to be a cyclo. We number from the point of attachment. We could go left or right. We have to go left because we're going to give the double bond, which is the higher priority feature, the lowest number. So 1, 2, 3, 4. So we have a 2,4-diene. Okay, and there's 8 carbons. The ring means it's cyclo. 8 carbons would be oct, because the 2 double bonds will say octa, and then we'll say 2, 4. We got some stereochemistry. So on this bottom part here, easily this is the higher priority group. Up here, it looks a little different, but I have a double bond over here. So that's the higher priority group. The 2 are on the same side, so this would be a 2Z. This is pretty clearly the opposite sides, so this will be a 4E. At this position right here, 1, 2, 3, we draw a little line. This is substituent, 1, 2, 3, 4, 5. So that'll have the name of pentyl with a number for it, 3-pentyl. All that's going to be in parentheses with a number down here in front of it. And then at this position right here, we have a single carbon, that's a methyl substituent. Okay. If we come over on the other side, we have a benzyl. You just got to know that. And then we come down here, number from the point of attachment, number up to the double bond. It's 4 carbons, so it's a cyclobutene. The ene is at the 2 position. So cyclobute-2-ene ill. And then as I go across, 1, 2, 3. 3 I have 1, 2, 3, 4, 5, 6. I have a 6 carbon chain, which is a hexyl. That'll be a 3-hexyl. And at the 4 position, I have 2 1-carbons methyls, 4,4-dimethyl. Okay, so let's take a look now at what this is going to look like. So again, here you can see my numbering system. You can see the sub-branch on the branch, and there's the name for it. If I keep going down the line, here's the name you have to know for a simple aromatic ring. And when we get to the ring, we number point of attachment, go towards the pi bonds. That's a Z, that's an E. We have a 5-carbon branch there, so this is a 9 position here. 3-pentyl in the branch. Cyclo, because it's a ring. Octa, because it's 8 carbons with 2 pi bonds. 2Z, 4E. Di, because there's 2. Ene, double bonds. Ill, because it's a substituent. Okay, so that all goes together. And then at 10, we have a methyl. If we come over to the other side, this is also an aromatic ring, but there's a CH2 here, so this is called benzyl. Okay, remember, always start at the C double bond alpha 1. We go down the line. Here's a 5 position for the double bond. That's an E. And then when we look at this position, numbering from 1, we count up towards the double bond. So at double bond's 2, but the branch is 3, and that's a hexyl. Okay, so we're going to have a 3-hexyl. If we look at the methyls, we have 4,4-dimethyl, ring, cyclo, 4 carbons, bute, 2 position of the double bond, YL because it's a substituent. Okay, and the whole parent name is 12 carbons, so that'll be dodes. Okay, dodes, 5-ene, and then 10-ine, always ene, ine. And then we drop the E on the ine and add the suffix for the ester, which is O8. Okay? So then our name looks something like this. So if you didn't follow all that, then go a little slower. Okay? try and trace your way through this name, because this is real important. This is the foundation that we're going to add the functional groups onto. Now when we come along and put the functional groups, it's going to look a lot more complicated, but remember, each functional group has a prefix, and all you will do is the number where it's at and the prefix name, like a deck of cards. So just learn those cards, learn those functional groups. Okay? So now here's our new example where I've added a lot of stuff. So if we start, again, it's an ester, so I haven't changed that. It's mostly the same. There's a few little changes in this one, but not much. Okay, so that means the branch on the oxygen is named first. So I have to number this from the point of attachment, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It looks like I should go into here for 12, but this is a whole functional group. So I can't name the functional group as part of the longest chain. I'm going to make a break right here. This happens to be an acid chloride. So as I go down 2, I have something. So you should know what this is. This is a thioether, and we named those as the alkyl group thio. So this will be ethyl thio. We already named this, but notice out here I have an NO. That's a nitroso. So I have a number, nitroso. I have an NO2, which looks very similar, except 2 oxygens. So that's a number, nitro. That's all you got to do. And then all that will be in parentheses. When I get here, and I have an NH2. So NH2 is going to be an amine. Very simple prefix, amino. So I'll put a number, amino. Excuse me again. And at the next position, I have an amide. Also very easy prefix, amido. So I have a number, amido. On this one, you could call it carbamyl, but most people prefer amido. Here's our old aromatic ring again, benzene ring. That's a phenyl. Now remember the ketone prefix is oxo. Okay? And then I come to this complicated looking one. I go 1, 2, 3, 4, 5. 5, I have this group right here. So this is also an ester. Notice I have an ester here as our high priority group with all this other stuff. But I have an ester as a branch. So esters as branches are pretty easy. There's a group right here that looks kind of like an ether. We even name it sort of the same, methoxy. But then we have to put in carbonyl for the C double bond O. So we call this a methoxycarbonyl, and that's the ester. And as substituents, I'll only give you really simple esters to name. Now notice here's an aldehyde, but this aldehyde is a branch. Okay. There's also, if you look way over here, there's an aldehyde here too, but that's part of the longest chain. That's at the end. So this branch gets its own kind of name. This is called formal. And notice it has to be just one carbon because it's attached to something, and the H and the double bond O are fixed. So this is going to be a number formal. And everything else is kind of the same as we did in the previous example. I threw in a halogen here. This is bromine, so this will be a number bromo. And then right down here, we're going to stop. I think that was 11. So we'll say 11. And then this is kind of like the ester up here. We name the chloro, and then a double bond O, carbonyl. Chlorocarbonyl, methoxycarbonyl. Okay, so they have kind of a similar strategy. If we come over to the other side, we already saw this. This is benzyl. But now I have an N3. So remember, N3 is azido. So I need a number, azido. 1, 2, 3, 3 azido. 4, I have this, which is an alcohol. Alcohol has the prefix of hydroxy. Remember, not hydroxide. So 4, hydroxy. And then here we come to, looks like sort of a carbon branch, but there's an oxygen in the middle. This is an ether. So remember what I said about ethers. You name it like it's an alkyl branch. So this would be 1, 2, 3. That would be like a propyl. And then there's a 2-methyl. But because of the oxygen, we take the YL and make it oxy. So this is a propoxy, 2-methyl propoxy. And then here I have a cyano. Whoops, I didn't want to do that. Here I have a nitrile, which has a prefix of cyano, so number cyano. And then we come to the chain that we had before. Nothing different there. And then I have a thiol, like a sulfur alcohol. If you look over here, alcohol, here's a thiol. And so that has a prefix, 2 possible ones. I use mercapto, so I'd say number mercapto, or the more modern one is number sulfonyl. Here's that ketone again, so that's going to be an oxo. And then I have the triple bond that will go at the end. And then I have an aldehyde in the chain, so this will also be oxo. So in fact, we have 2 oxos here. Okay, so this is 12, 11, 10, 9. So this might be a 9,12 dioxo. Okay, so notice I'm not really changing anything in the name. I'm just sort of putting in all these prefixes at the front. So if you know those and you feel comfortable with those, this should not be too hard. The problem is learning the patterns, recognizing them fairly quickly, not struggling to understand what they are. So that's why you want to know your functional groups. So let's take a look. Okay, so on this side over here, I notice I put in all the numbers. That's what you want to do, because you're going to need those numbers to identify all the positions. Okay, so if I start on the oxygen branch, number 1, and then 2 I get here, so notice 2-ethylthio. And then here, this looks pretty much the same, except at the 5 position I have a nitroso, and the 6 position I have a nitro. So I go 4-ethyl, 5-nitroso, 6-nitroheptyl. Pretty much the same. I have the amino group at the 4 position. I have the amido group at the 5 position. Very easy to mix these up. Okay, I see it all the time. Remember, the amido group has the double bond O. And then here's our familiar benzene ring, which we call phenyl. And then there's the ketone, oxo. Notice 8-oxo. The numbers are just right off this chain right here. At 9, I have a complicated group, which we mostly named. All we have to do is add in these 2 additional groups. So we go around. At 5, we see methoxycarbonyl. 5-methoxycarbonyl. At 6, we see 6-formyl. 6-formyl. And then cyclooctadiene and so forth. 10, very easy, 10-bromo. 11, we have the chlorocarbonyl. Okay, so remember, this is not part of the longest chain. Very easy to confuse. So chlorocarbonyl. And then we have 11 carbons, so that's undeca, because there's 2 double bonds, the dienyl. Il, because it's a substituent. On the other side, we have the benzyl, the 2 position. 3, we have the azido. 4, we have the hydroxy. 5, we have the 2-methylpropoxy. Okay. 6, we have cyano, prefix for nitrile. 7, just the same as we had before. 8, we have mercapto or sulfonyl. And then we have 9,12-dioxo for the ketone and the aldehyde. And then the chain is 12 carbons, so we say do-des, and then for the double bond and the triple bond as we did before. Now you'll notice in all these functional groups I did not put in an acid. The acid only has one side, because the acid has a COOH, so there's only one direction you can go. And that's why I don't usually use acids, because I'd have to cram all of this into one very, very long chain. So my typical questions result in anhydrides or esters. Okay? So I put here the places where we had a couple possible names. If I had something like this, very simple example, I have a 4-carbon chain, so that's butane. I drop the E and add oic acid, butanoic acid. In this example, I put in an OH just to show you again. We have 2 kinds of OHs. So this would be an alcohol 3-hydroxy, which we named up here. Okay, hydroxy. Every time you see the alcohol OH as a prefix, it'll be hydroxy. Okay, so let's take a look at one more example. This time you'll notice there's only one functional group. So again, what is that functional group? Acid, amide, aldehyde, ester. No correct answer. It's no correct answer because this is an anhydride. Now there's 2 chains to name. I would separate right here at the oxygen. So I start at 1 on this side for the carbonyl, and I start at 1 on this side for the carbonyl. And then I go in the longest chain that has any functionality here. This would be a branch. And same thing over here. So I go in the longest chain that has functionality. Okay, and then there's a ring. That's going to be a branch, and this is going to be a branch, and this is going to be a branch, and so forth. Okay? So 1, 2, 3. 1, 2, 3, 4, 5, 6. And then I have a cyclopentyl, hexyl, at the 3 position. My double bond, now what is it going to be in terms of stereochemistry? 1, 2, 3, 4, 5. This is easy. The big group is on the bottom here. Over here I have to compare these 2 groups. They're both CH2s. This one goes to a CH3, but this goes to a more complicated center. So this will be the major one here. So that's opposite sides. That would be E, 5E. When I come down here, let's stop here. Point of attachment, 1. Now I'm going to go down to the right because I get a lower number for my double bond. 1, 2, 3, 4, 5. And this would be E, and this would be Z. Okay? And then when I get here, I have to compare these 2. And I have 1 carbon and 2 hydrogens, or 2 carbons and 1 hydrogen. This would be the higher priority. And this is a methyl versus an ethyl, so this is higher priority. So that's going to be a Z. All right? On this side over here, we have a phenyl. And then we have a very simple branch, 1, 2, 3, 4, 5, 6, 7, 8. That'll be an octyl. I have a double bond. So the double bond going to be, if I go CH2, 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 more complicated. So this is the higher priority part of this carbon of the double bond. And over here, this is pretty clearly the higher priority part. So that's an E, stereochemistry. And then down here I have a triple bond. So let's take a look at how this will be named. Okay, so starting on one side, let's start on the right side here. Is that what I did? No, I started on the left side. So let's start on the left side. So 2, I have a phenyl. Okay. 3, 4, 5, I have an octyl. Very simple. The carbon is 13, the chain is 13 carbons long, so that's going to be a tri-dec. So tri for 3, dec for 10. 13. And then at the 5th position, I have a double bond. We said that's going to be an E. So 5E, ene. 10, I have an ine. Always ene, ine. I drop the E and add the suffix oic for the anhydride. The suffix for the anhydride and the carboxylic acid are identical, oic. But for the anhydride, we'll have another one. We'll have 2 of them. So now we're done there. Ine, oic. I come to the other side. 1, 2, 3. Okay, I count up. That's 6 carbons. That's hexyl. But at the 5th position, I have a cyclopentyl. So I have a 5 cyclopentyl hexyl. 6 ethyl. Very easy. 8. Now I'm going to number 1 and go down to the right. So that is 9 carbons, and there's 2 double bonds. So it'll be a cyclo, non, na, and then 3E, 5Z, di-ene, substituent, il. Okay, so just break it down to its parts. And then at 9, I have a very simple benzyl. And at, whoops, I called that 1. It's really, this should be a 10. 10 methyl, dodeca, because there's 2 double bonds, 5E, 9Z, di-ene again, di-ene oic, and I have 2 of those, and then anhydride. So I can tell this is not a carboxylic acid because I had 2 of them and I said anhydride at the end. Now what we're going to do is the same thing we did before. This is our foundation, and we're going to add on our functional groups. So they're going to be the same functional groups we did above, the same prefixes, but different numbers. Okay, so you want to know your prefix, you want to know your functional groups and their prefix name. Okay, so let's take a look. Oh, I just wanted to mention down here, if the anhydride is symmetrical, I just did a real simple one. These are propanoic. So, we'd say propanoic, anhydride. But when they're both the same, they just say it one time. Okay, just wanted to point that out. So now, what did I do? Oh my goodness, look at all these functional groups again. Here's a thioether, and here's a thiol, and here's an amide, and a nitro, and a branch aldehyde, and an azido, and a chloro. And on this side, we have the ketone, oxo prefix, the alcohol, hydroxy. Up here, we have an ester, methoxycarbonyl. We have a nitrile, cyano. We have an acid chloride, chlorocarbonyl, amine, amino. And then this time, 1, 2, 3. 3-carbon chain is propyl. 1 position has a methyl, so 1-methyl propyl, but because it's an ether, 1-methyl propoxy. I have a nitroso, and I have an aldehyde in the longest chain. Okay, so these are all things we've seen before. If you've worked through that other example, which I would suggest you do it until you can work through without any help, that you can do it completely on your own. And then come down and approach this one. This should be pretty much the same. Okay, this should reinforce what you've learned in the first one and kind of solidify your ability to name these complicated structures. Okay, so in this compound, I tried to put in a lot of our functional groups. I have an anhydride, an ester, an acid chloride, an amide, an nitrile, an aldehyde, a ketone. Actually, aldehyde 2 ways. Okay, I have an aldehyde branch and an aldehyde in the longest chain. Aldehyde, ketone, alcohol, thiol, amine. Don't mix up amines with amides. Ether, thioether or sulfide. Halogen, a nitro, nitroso, an azido, an alkene, an alkyne. We have aromatics, we have branches. Okay, it's got just about everything you need to know. So you should do very well if you can name this. So let's take a look at the name. Okay, so again, I put in all the numbers, so you want to be familiar with that. Okay, work through every single step. 2, I have a ethyl, thio. I have a very simple branch here. I have the thiol. Okay, this is a thioether, or sometimes called a sulfide. This is a thiol. like a sulfur alcohol. So this is mercapto or sulfonyl. Here's my amido, 5-amido, simple branch, 6-ethyl, 7, I have a nitro, 7-nitro. Now in this one, we have an azido, and I'm numbering towards the double bond or the highest priority group. So in our previous example, there was no functionality here, and we went down to the right because that gave us a lower number for the double bond. But notice in this example, we have an aldehyde over here, and so when I start numbering, I'm trying to give whatever the highest priority feature of this ring is, the lowest number. So in this case, we're going to go to the left. 1, 2, 3, 4, formal. 5, 6, 7, azido. And then pretty much the name is the same. We have a, oh, what's about the double bond here? This was an E double bond before, but now with the nitrogen over here, this becomes higher priority. So now this is going to be an 7Z, because the two higher groups are on the same side. And this is still the same, 5Z. Okay, we have the benzyl, 9-benzyl. We have the 10-methyl. Get down to 12, and we have a chloral, 12-chloral. Okay, so is that the one I did first? 10-methyl, nope. Okay, that's the second one I did here. So 2-ethylthio and so forth as we go through there. So check each one of those, make sure it's understandable to you. Now let's go on the other side. So on the other side, again, we start at the C double bond O. Now this is tricky because I have a double bond O, double bond O, double bond O, and you go, wow, there's, you know, what's going on here? But notice this one has the oxygen in between the two double bond O's. So this is just sort of a confusion. This is a ketone. It's between two carbons. So we start here at the anhydride carbonyl. 1, 2, phenyl. Okay. 3, oxo. But then I always look down the line for any other oxos, and I find one at the end, 13 here. So 3, 13 dash dioxo. And then 4, I have a hydroxy. And 5, what do I have at 5? 5, I have this long chain here, which is 8 carbons with a branch. That's an ester. So esters are named methoxy, whatever it is. Could be alkoxy, could be an ethyl group, ethoxy, but this one's methyl. So methoxy carbonyl at the 3 position, 3-methoxy carbonyl. And then the branch is octane, drop the A-N-E-Y-L, octyl, for substituent. Then we come here, we have a nitrile, which we're going to name as cyano, 6-cyano. And then here we have an acid chloride, we're going to call it a chlorocarbonyl, 7-chlorocarbonyl. 8-amino, not amido, 8-amino. 9, what do I have? 9, it's like a alkyl branch, 1-methylpropyl, but the oxygen there makes it 1-methylpropoxy because it's an ether. So 1-methylpropoxy at the 9th position. And then 12, we have a nitroso. It's a 13-carbon chain, so we call it tri-des. At the double bond here, okay, now what's the stereochemistry? We have an oxygen on this carbon, that's going to be higher than this. So here's our higher priority one on the bottom. Over here, we have a carbon with 3 nitrogens, or a carbon with 2 carbons and a hydrogen. This is going to be a Z. So the 2 higher priority sides groups are here, same side. So that'll be a 5Z. Okay, and there's a 5Z right here. And then at 10, we have an ine, and because it's an anhydride, we call it oic. So both names end in oic, 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 and then we say anhydride. Okay, so again, here's the groups with a couple different names that you can take a look at. Okay, so this last example, I just wanted to throw in all these complicated prefix guys. So I just threw something on every single carbon just to give you, again, an example to look at. Okay, first off, highest priority group. So when I look down the line, I got a lot of functionality. But the highest priority group is the acid down here. That's at the top of our column. So that's going to be 1. And then I count all the way to the end, and that would be 17 carbons. Okay, 17 carbons would be hepta, and then 10 carbons, decane. Okay, so if I didn't put any double bonds or triple bonds, just because I'm looking at the functional groups. So now, do you know these functional groups as we go down? I'm going to go through them pretty quickly, just to save time, and then I have the answers down below. So 2-hydroxy, 3-chlorocarbonyl, 4-chloro, 5-amino, 6-amido, 7, this is a methyl group, methyl-thio, It's a thioether or sulfide. And then 8 is an ether, methoxy. 9 is an ester branch, methoxycarbonyl. 10 is a nitrile, cyano prefix, 10 cyano. This is a thiol, prefix is mercapto or sulfonyl, 11 mercapto. 12 oxo. 13, now this is a branch aldehyde, so this will be formal. 13 formal. 14, and 3 is azido. Notice I put in the formal charge in one of the resonance structures. 15 is 1 double bond ON, that's nitroso, 15 nitroso. 2 oxygens on a nitrogen with formal charge and resonance, 16 nitro, and 17 would be oxo because it's in the chain. So this oxo and this oxo would go together as 1217 dioxo. Okay, so let's take a look. You can go down the line and see I put in the different names so that you could check those out, and I wrote it all out in order of appearance. I didn't do anything alphabetical, and I would prefer you do it that way too. And then I get down to the end. So it's a hepta, that's for 7, and dec for 10, decan, no double bonds, triple bonds, oic suffix acid. Okay, so I hope that this helps you go through these complicated names. You might have to look at this multiple times. I would pick that first structure and do that one over and over and over until you're very comfortable doing it, and then try the second structure. This is just to check your prefix functional group names. Okay, so good luck on that.